cloud. Okay, so we've got the record button in the upper right hand quadrant of our Zoom screen, which indicates that we're recording. And so let me jump back in to the shared screen. Oops, and let me pull this stuff out of the way. Okay, there we go. All right. So for the benefit of those who are watching the recorded version, this is Mech Design 2. We are entering into a new module, having gotten through the creative module. We're now into the down selection to preliminary design module, whose principal goal deliverable is the preliminary design report, the PDR. And so as we transition out of kind of the creative portion of the class and into the more quantitative down selection matrix driven portion of the class, it's very natural to kind of talk about that transition in the of this way of thinking, which is called the Kano model. So the talk today is going to be Kano model for analyzing customer needs. So here's the lecture outline. I'm going to try to describe where the Kano model fits into the design process, why it's advantageous to us to apply Kano model thinking as we go through the design process. I'm going to explain how the model works, and then there's kind of three different needs that are defined by the model. Go through each of those, and then I'm going to share with you kind of this weird, interesting feature about how the needs actually migrate over time. So attractive needs, performance needs, and ultimately needs. And I'll give you guys kind of a funny example of that. But the first thing that I want to just mention is where this Kano model fits into the design process. So you guys have seen this chart from me before. This is our engineering design process that covers both Mech 2 and Mech 3. The green dotted line is kind of the separation between Mech 2 and Mech 3. Mech 2 is on the top, Mech 3 is on the bottom. And we'll, over the course of the semester, march through all of these 11 steps to get to the final design review. So this is that final oral and written presentation that you guys will give at the end of the semester that I was talking about a little while ago, the one that'll happen in August. And so where are we now? Well, you guys have now submitted your CDR, your concept design report. So you guys have basically gotten through step number 6, and where you would normally be in the design process if you were working at a company with a customer is you would have a well, I would say an in-person review, but now probably a virtual Zoom meeting type review, where the customer would tell you what they think of your ideas, and if the customer likes your ideas, then great, that's a good outcome, and we're going to then move ahead to the down selection process, which is kind of the big quantitative difficult thing that you have to do in the preliminary design report. But if the customer does not like your ideas, then you sort of kick back. It's like chutes and ladders, right? You you slide back down the slide here, no, all the way down back to step number 4, which is concept generation, and go through another brainstorming process. So our challenge is that okay, yes, we have direct contact with Dr. Nimi, but Dr. Nimi is not the instructor of record for the course. And so you guys have basically got us, the teaching team, going through your CDRs and telling you whether they're good or not. But I'm not in the UF soft matter engineering lab. I can't tell you what's going on in the mind of Dr. Nimi or Dr. Sawyer or Dr. Angelini. And so we're sort of missing this vital element of feedback that tells us that we're on the right track to move forward to down selection. And so the Kano model, in a way, kind of serves this purpose of helping us think about like the psychology of the customer and whether the customer will actually like the ideas or will reject the ideas and kick us back down to this level. So so that's where this fits into the overall process, is in absence of kind of a meaningful interaction with the customer at this stage. We're going to use the Kano model here to tell us what the customer is most likely thinking about our ideas. Okay, so that's where it fits in. So now why bother with this? What is this, and why apply it? So there was a Japanese researcher who developed this in 1984, and he, with a group of colleagues, his name was Kano, by the way, hence the name of the model. Um, Developed this way of thinking, and it ended up getting published in the Journal of the Japanese Society for Quality Control, um, in Japanese, right? So we have to find a translation for it if we want to read it in English. There's all kinds of follow-on work that's in English. I have a number of papers that I found that are pretty interesting, that follow on this original work. So it's now kind of easy to navigate your way through this. But the paper was called Attractive Quality and Must Be Quality. And that's, of course, the Japanese to English translation. But the underlying concept, the kind of why we need this model, is that to compete, we have to understand customer needs as product designers, oftentimes better than our customers can articulate them, right? So we have a customer needs statement. This happens all the time. The customer will actually tell you what they want, and you'll get all the way through to this step in the process, right? You've got your concepts and you're meeting with the customer for the first time, and they'll tell you that they hate it, right? It's like, I hate this thing that you've created. It's not what I wanted at all. And you look at them and you're like, this is crazy. I've met all of your customer needs. I've got subsystems that are connected to metrics that are connected back to the customer needs. How could you hate this? And it turns out it's because at a subconscious level, and sometimes even at a conscious level, customers have priorities and they attach meanings to certain features and functions and outcomes that they don't properly articulate when they first come up with the customer needs statement. And so the Kano model is kind of a way of thinking about the unspoken, unwritten, unarticulated customer needs that will emerge kind of once customers begin to dig into the design process with the design engineers and kind of realize what they really want, is really what this is about. And so I mentioned this before, but I think the reason, particularly for this class, for the summer class, that this is so important, is I think some of you know about the bet that I have with Dr. Nimi. So our challenge in this class is that you guys are preceded by a group of students in the fall who had probably an easier but similar set of customer needs to develop a microscope mounted 3D bioprinter. And those designs, the best of those designs, have already propagated forward into design 2. No, this is design 2. They've already propagated forward into design 3. And there's sort of this sense in the design 3 class, and Dr. Nimi teaches that class, that he's got the best 6 designs, right? And there's nothing that can be done that's better than those 6 designs. And so you guys are kind of in a way, kind of a disadvantage, a psychological disadvantage, in that you're coming to the game kind of late, right? And so it's very possible, right? I mean, this is kind of what Dr. Nimi is expecting is going to happen, that you guys are going to go through your process and you're going to come up with these designs for your 3D bioprinters, and they're not going to be so substantially different from the ones that he already has, that have already gone through the Mech 3 vetting, that he needs to take any of yours and move them into the prototyping phase. I think that that's not going to happen. I think that at least one group, and hopefully more, because this is a very strong class, I've said that before, I think you guys are going to come up with something that's going to absolutely blow him away. And I think he's going to be forced, based on your creativity, to adopt at least a couple of the designs that come out of this class for Mech 3. And so I'm so convinced of that I actually made him a bet, that once he sees your designs, that he will want to adopt at least one of them for prototyping in Mech 3, even though he's already got his 6 favorites that he likes. And so that's this bet that I'm talking about that I have with Dr. Nimi, that he's going to adopt at least one of the designs out of this class. He thinks he's not, but we will prove him wrong. The reason that this is important is because this is pretty much what happens in the real world, right? Very rarely do you, as a designer, come to a problem and discover that, like, the field is wide open, right? There's no competing products at all in this particular market, and you are the very first one to enter the market with some new idea or new technology, right? That very rarely happens. If you look back kind of through history, I'm fascinated by Edison and Tesla and the invention of the light bulb and AC and DC electricity, because a lot of my original work right when I graduated from school, as you guys remember from my Next Tech Power Systems presentation, involved internal lighting and alternating current and direct current. But even like the invention of the light bulb, right? Edison, yes, okay, invented the light bulb in air quotes, but there were several electricity powered internal illumination technologies, arc-based illumination technologies that predated the invention of Edison's light bulb, right? So it's not like he was just coming to this world where there were absolutely no competing technologies. And of course, there was a whole world of wax candle based lighting technologies and oil based lamp technologies that the light bulb had to compete with. And so almost never in the real world are you going to come into a market, a space where there's no competing products. And so I think in a way, this is actually better for you guys to know that there's already these 6 3D printer designs out there in Mech 3 that are being vetted through the Mech 3 process, because it's precisely what you're going to encounter when you get into the real world. If you go into the world of design, you are always going to be faced with a situation where you're having to create a new niche in a market where products already exist. And so the Kano model can help with that kind of thinking. How do you create a product that is competitive against a background of pre-existing products that have basically saturated a market? Okay, so I've been sort of talking about the why here. Let's talk about what the model actually what it is. So here's a visual representation of the Kano model, and it kind of looks cartoonish and goofy here, but I'm going to break it down into its individual components, and you guys will see it's actually very serious and not nearly as complicated as it looks like. So the first element is the axes. So we have what's effectively a horizontal axis and a vertical axis. The horizontal axis measures the product's ability to execute a customer need. So I've kind of truncated that into need execution. But if you think about the 20 or 21 customer needs in the 3D bioprinter project, this axis represents each individual customer need and how well a particular subsystem concept executes that need. To the far left is very poor execution or no execution at all, right? So this is if you've just completely ignored something, one of the customer needs is completely ignored, or if you kind of recognized it but you haven't done a very good job of executing it. And then here on the far right is if you executed that customer need very well. So that's the horizontal axis. The vertical axis is a measure of the customer response based on, essentially their level of satisfaction. So if you go down in this axis, the customer is disgusted. So just appalled by how poorly that particular need, meets their expectations. And then here, if you go in the positive direction, the customer is delighted, right? Thrilled with how well this product meets their expectations for this particular customer need. So those are the axes. So now that we have a sense, so let me stop there. So can I answer any questions about the axes before I move on? How to navigate them? No. Okay. All right. So we're now going to, so if we remember the original model, I've now got these two underlying axes, which I've represented here in black. And now I have to map various types of needs onto kind of that background field. So the first one I'm going to talk about is this one that's in blue, which is called performance needs. So what I've done is just kind of isolated performance needs all by itself so that you can see where it lives on the map. And I have tried to be very conscious about using um, red and staying away from using red because I recognize that there's a couple folks who have difficulty seeing red. So I've tried to keep things kind of blue and purple and other colors that are hopefully visible. So hopefully the color scheme works. So performance needs I'm going to represent here in blue. And what are performance needs? Well, performance needs can either satisfy or dissatisfy the customer depending on how well they are executed. So if you look here, if you execute a performance need very poorly, you expect a negative customer response. And if you execute a performance need very well, you expect a positive customer response, right? So it's sort of linear in that respect. They are usually clearly articulated by the customer in the customer need statement. So these are the ones that you're actually going to see appearing. These are the needs that you're going to see appearing in the customer need statement. These are the needs that are consciously evaluated by the customer when they're deciding on product alternatives. So, you go to the store to decide between, my wife has bought a lot of beans recently because we're in, kind of COVID emergency mode. And so we have an entire pantry full of cans of beans now. And you look at two different cans of beans and you think about, okay, these two cans of beans are both, for example, kidney beans. Well, this can is cheaper. Can A is cheaper than can B. Can A is larger than can B. And so I'm going to buy can A because it's both less expensive and larger in volume, right? So it's those sort of conscious decisions that you make when deciding between product alternatives that are usually represented in the performance needs. And then often, the more of these, the better, right? So the more that you can execute a good number of these well, the more favorable your product is, right? So if your can of beans is both less expensive, larger in terms of volume, and the beans are, let's say, more nutritious, right? You've got three good qualities. Those tend to kind of stack up and compel the customer to buy that particular can of beans, as opposed to one that's smaller, more expensive, and the beans are less healthy. Okay, so let me give you guys an example in terms of the customer needs that we have for the 3D bioprinter. I just picked the need linear accuracy, and we know that from our customer need statement, the linear accuracy of our 3D bioprinter has to be better than 1 cell diameter, and we've quantified that. Different groups have quantified that in various ways, but that's the overall customer need. So if I were to execute this customer need, relatively well, right? So at least, I achieve this need. I would have a linear accuracy that's better than 1 cell diameter. And so, I'd be executing the need and the customer would be kind of moderately happy about it because, that's what he asked for. If instead I executed the customer need by coming up with a 3D bioprinter that has a linear accuracy that's better than 10 cell diameters, right? Not 1, but 10, right? So it's much less accurate. The customer specifically asked for 1 cell diameter. I gave them 10. It's not good, right? Because I'm less accurate than I was supposed to have been. I am not executing this customer need very well. And as a result, my customer is upset. They are disgusted with me. And they're probably not going to buy my product because it doesn't do what they asked it to do. By contrast, if I kind of blow the lid off of this customer need, the customer was expecting linear accuracy better than 1 cell diameter, and I give them linear accuracy better than 1/10 of a cell diameter, that is a great execution, right? Amazing execution. And the customer is going to be very excited and delighted about that. And they're probably going to end up buying this product, at least if this is their principal customer need. So you can see it's not necessarily linear in kind of a quantitative sense, but it's linear in kind of a graphical qualitative sense. If I'm doing the job badly, the customer is going to be disgusted. If I'm doing the job, okay, the customer is going to be reasonably content. And if I do the job really well, the customer is going to be delighted. And it's sort of that qualitatively linear relationship that defines performance needs. Okay, so before I hop on to the next one, can I answer questions about performance needs? Good so far. Okay. I'm looking at the time. I talked a whole bunch in the beginning, and we are going to bleed over just a little bit into the open lab hours. But I want to make sure that we get through this. So just bear with me, and we will make it to the end in not too much more time. Okay, so given no questions about performance needs, we're going to move on to the basic needs. So I'm going to bring up my same axis. I'm going to have the performance needs on there since we understand what that is now. And then I'm going to add this kind of logarithmic asymptotic curve that represents the basic needs. And these are needs that must be met. So what does that mean? Well, basic needs are what I would describe as the threshold attribute. So this is, you guys always hear the phrase like, this is the price of doing business, right? I have to pay my taxes because that's the cost of doing business or the price of doing business. Meeting these attributes or having these needs in place is basically the price that your company has to pay to even get your foot in the door and sit down at the negotiating table and talk with the customer as a viable provider of this particular product, right? If you don't have these attributes, the customer isn't even going to talk to you. So they're very fundamental, very basic, but they have to be there. These are needs that are taken for granted, and they're expected by the customer in all of their products. And as a result, oftentimes they're not even mentioned in the customer needs statement because they're sort of like obvious, at least to the customer. They're obvious. And so, why even articulate them when everybody knows that, a widget should have these particular features? The only time that the customer will mention these to you is if you forget to include these needs in your design. So you've essentially violated this kind of unspoken understanding that they'll be there. And then your customers will tell you, and they'll tell you very angrily that you've forgotten to do this very simple thing. These needs do not increase satisfaction, so you can execute them really well, and it doesn't matter, right? The customer expects them to be there, and even if you do a good job at them, they could kind of care less so long as these needs are there and are met. So let's look at an example, and this is interesting because we actually added this as a customer need this semester. It was not present in the fall because it was one of these needs that was just sort of assumed to be in place, which was the idea that the 3D printer has to operate in a biosafety level 1 clean room environment, right? So we did add this as part of the customer needs now, but it wasn't there in the fall. Because this was just assumed, right? So this is a great example. So how does this work? Well, if you guys came up with a 3D bioprinter that was entirely compliant with BSL-1 standards, it would operate very happily in a clean room. It wouldn't cause any spills. It wouldn't create any effluent, and it wouldn't foul the space of the clean room. And that's great. But that's exactly what the customer expects, right? They don't want to put a 3D bioprinter in their clean room that's going to mess up their BSL-1 clean room rating. And so even if you are executing this really well, you've come up with a 3D bioprinter that maintains the clean room environment, your customer isn't going to care, right? Because that's what they're expecting. In contrast, if you have a 3D bioprinter that generates a bunch of smoke, that pollutes the environment, that spills all kinds of oil and gas and water and stuff all over the floor every time you use it, messes up the clean room environment, your customer is going to be very upset, right? Because they are expecting this thing to operate in a clean room. They brought it into the clean room, they turned it on, and all of a sudden it's turned into Willy Wonka's chocolate factory. It's a mess. That's kind of an example for this particular customer need of how a basic need works, and explains why it has this kind of asymptotic relationship on the negative side of need execution, and then on the very negative side of customer response. Okay, so before I move on to the next one, can I answer any questions about basic needs? Nope. Okay. I'm either doing really well or you guys are asleep. Okay, so the next need is attractive needs, and this is the one that's really cool, that I think is going to help us quite a bit in our thinking with respect to how to get some of your 3D bioprinter designs propagated into Mech 3. Okay, so here's what an attractive need looks like. So it's the one that I've represented here, kind of this orangish yellow, and it is also asymptotic, but it trends kind of to the zero side of customer delight if you go very poor in terms of your execution, and it trends asymptotically towards the being very delighted if you execute it well. And so to do this, because remember, attractive needs, if I go back, oh no, we haven't talked about this yet. Hang on, I've got this out of order. Let me move this here. There we go. Okay, the power of PowerPoint. Okay, so so attractive needs. So what are attractive needs? So attractive needs are innovations that give products a wow factor, right? So something that's unexpected, unanticipated, and from the customer's perspective, delightful when it's delivered. Um, if these needs are missing, the customer usually doesn't even know about it and doesn't think about it. So the customer is not dissatisfied if these needs are not there. And oftentimes the customers don't even know that one of these needs is something that they want, right? So they're typically unspoken by the customer and absent in the customer need statement. I think it was um, um, Steve Jobs, Apple computer Steve Jobs, that said something to the, I'm going to botch this quote, but said something to the effect of customers don't know what they want until they're shown it, right? Until I show them it. So this is kind of that idea, right? The customers don't even necessarily know that they want this particular feature in their 3D printer until you as the design engineer show them this feature, and then all of a sudden they're wowed by it. And this makes the difference between having basically a product that's a commodity, and a product that is innovative in its design space. So you guys hopefully have already listened now to the hedgehog concept section out of the Good to Great book by Jim Collins, and listen to the series of lecture presentations. Uh, Benny Lagoy, who's one of our graders, who made those slides and narrated them on the hedgehog. Um, I am kind of mixing ideas here, but I feel like an attractive need that you guys come up with could actually be a hedgehog concept for your 3D bioprinter. So I would really like you guys to kind of think about the overlap between those two ideas that I presented in the class as you're thinking about your hedgehog concepts. You actually have to come up with hedgehog concepts and present them in your preliminary design report. And so your hedgehog concept may very well be an attractive need, right? Your 3D bioprinter does something that the customer did not anticipate, that is uncanny, that is amazing, that just floors people. And I think if you do that and you build your entire design around that hedgehog concept and demonstrate that you can do it well, better than anyone else in the class, and that it's something that you're passionate about, and it's something that can drive the product forward. Those are the three circles of the hedgehog concept. I think that is the winning combination to get your designs into Mech 3, even though there's already products in that space. So to me, like, this is the thing that I really want you guys to be thinking about, is how you can come up with attractive needs that are also hedgehog concepts. And so this is basically what I've been saying all along, is that for 2020 summer, the 3D bioprinters must be rich in attractive needs for for Trom to win the bet, right? For me to convince, and for you guys to convince Dr. Nimi that he's going to want to adopt some of your designs moving forward for Mech 3. Okay, so what does this look like? Well, boy, these are all messed up. Here, let me, somehow I got these out of order. Okay, let me put this here. Okay, so here's our attractive needs curve. And in order to come up with kind of a 3D bioprinter example, I had to make up a customer need that's not on our customer need statement, right? Because remember, attractive needs are unspoken by the customer because they don't actually know that they want that need. They haven't thought about it yet. So the one that I came up with, and you guys are free to borrow this if you want, but I would prefer you to generate your own, is there's a customer need that says that okay, we're gonna 3D bioprint living cells. Okay, great. Up until now, all of the bioprinters have been designed around kind of this underlying assumption that we're only printing one type of cell at a time. Like, okay, certainly you can switch out, fibroblasts for cancer cells, for, amoebas or whatever, but never, at least in the context of UF 3D printers, 3D bioprinters, and I think even the ones that are available on the market, has anybody come up with a 3D bioprinter that can simultaneously print multiple types of cells, right? So that, I think, has this wow factor that would differentiate a 3D bioprinter coming out of this class from the ones that already exist. So that's the customer need. And I use customer need very loosely because it's not a customer need in the conventional sense that this exists in the customer need statement. But it's something that I think would be really impressive, that I think that we could execute in this class that would make your 3D bioprinters compelling and competitive against the ones that are already on the market. And again, you guys should come up with your own ideas. I think that you guys can come up with multiple good, attractive needs, but this is the one that I wanted to use as an example. So where does this fit? Well, if I'm 3D bioprinting with just one cell type, well, that's what happens anyway, right? So I'm not executing this customer need particularly well, but this is an attractive need, and so the customer really doesn't even notice that this is not being executed well, and so has, kind of a null response to that. But if I can come up with a 3D bioprinter that prints, I said, N types of cells, right? So this curve would be like 2, 3, 4, 5, and then it get exponentially high as you get an exponentially differentiated number of cells that you can print simultaneously. I think that would be a really cool feature that I think the customer would be really excited about, the sponsors would definitely be excited about, and would cause your product to kind of explode exponentially in terms of customer delight on this scale. So that's that's my example of an attractive need. And for us, I think we probably need to think about like one or two, and it would be nice if they were different for each design. But I can imagine you guys kind of, unfurling this for the customers, and I can imagine people's jaws drop when they see kind of some of the cool things that you guys come up with that are above and beyond just kind of the existing vanilla set of customer needs that we've been given. Okay, so that's attractive needs. Can I answer any questions about that one before we move on to the last concept? So far, so good. Okay. All right. So the last thing that I just want to mention is that attractive needs do migrate over time. And so this is pretty interesting, actually, when you think about it. So we've got this potential customer need along the attractive needs axis of simultaneously printing multiple cell types, which at the moment is totally different and totally innovative and something that no 3D bioprinter as of yet designed in Mech Design 3 or Mech Design 2 has accomplished or even thought about. But what will end up happening over time is these attractive needs will drift. So I've got this arrow here that represents this sort of drift from attractive needs to performance needs to basic needs. So this is kind of forcing you guys as you go out into your careers and become design engineers and think about how to stay competitive in the design space. You always have to be wary of this drift of attractive needs over time, away from being kind of these exciting, compelling wow factor things to things that are just expected, to things that just basically become, you know, basic needs for every product in that particular space. And the example is Wi-Fi at restaurants. I think this is a funny one because it used to be that if you go into like this really, and this might be before your time, might be here a little bit, but it used to be that you would walk into like the really super duper high end, like $15 per cup of coffee, like, you know, private brand coffee shops, and those were the ones that offered free Wi-Fi, and nobody else offered free Wi-Fi. It was just these really high-end coffee shops, and so you'd buy your $20 cup of coffee, and you could actually sit there and you could sip on your $20 cup of coffee, and you could, you know, use the internet. But in general, even just a couple years ago, this idea that Wi-Fi is kind of ubiquitous and exists across all restaurants was definitely an attractive need, right? But time has marched on, and now everybody, including Taco Bell, right? Every single restaurant has free Wi-Fi, and that's now just expected, right? And if you walk into a restaurant that doesn't have free Wi-Fi, you're kind of disgusted, right? Because every restaurant should have Wi-Fi. It's the 2020s, by God. And so in a very short period of time, this thing that was an attractive need, this offering of free Wi-Fi at the really high-end coffee shops alone, has migrated through to become a performance need and then ultimately become a basic need. And now, even to compete, every restaurant, including Taco Bell, has to have free Wi-Fi. So again, just something to think about. You guys are going to be you know, kind of breaking the mold and pioneering some of these attractive needs. But you always have to keep in mind that those attractive needs are going to migrate over time. And so to competitive, you have to continuously come up with new innovations and push the envelope and continue introducing new functions to your products, or else very quickly your products just become commoditized and they're just meeting basic needs like all the other products out there, and then there's no differentiation that makes your product special and different and compels customers to purchase them. So you basically become Wi-Fi at Taco Bell over time if you don't stay innovative and careful. Okay, that's it. That's all I want to say about the Kano model. So can I answer any questions? No. Okay. Well, I haven't yet put these slides up on Canvas, but I will put them up here at the end of Open Virtual Lab Hours. Let me stop recording.